Good afternoon. Welcome to this hearing. Thank you to each of the witnesses for being here. On December 14th, 1972, before returning home, Apollo astronaut Gene Cernan took the last steps on the lunar surface and stated, "As I take man's last step from the surface, back home for some time to come, but we believe not too long into the future, I'd like to just say what I believe history will record, that America's challenge of today has forged man's destiny of tomorrow. And as we leave the moon at Taurus Littrow, we leave as we came, and God willing, as we shall return, with peace and hope for all mankind." These words are just as true today as they were in 1972. America's challenge during the Apollo era has forged man's destiny. That destiny, I believe, is to put American boots on the surface of Mars. It has been more than 4 decades since Gene Cernan left the lunar surface. NASA is once again looking to return to the moon in the 2020s and will use it in turn as a stepping stone to reach Mars in the 2030s. Even though we've been to the moon before, our return will not be easy. As a generation of engineers and scientists at NASA have since left the workforce, while the moon will provide a great testing ground in preparation for the journey to Mars, we must remain vigilant and ensure that we limit costly delays that could push a crewed Mars mission in the 2030s out of reach. Let me be clear. Mars is today the focal point of our national space program. And if American boots are to be the first to set foot on its surface, it will define a new generation, Generation Mars. In preparation of a crewed mission to Mars, NASA has been sending scientific robotic missions to the 4th planet in our solar system for the past 4 decades. Yet we still have much more to discover. Last month, NASA's Curiosity rover discovered organic compounds, which may be a sign that there was once life on Mars. While the discovery of organic compounds leaves scientists with more and more questions, it also leads us to believe that we may be on the right track. And just today, the journal Science published a report on radar evidence of subglacial liquid water on Mars. Using radar profiles collected from a satellite between May 2012 and December 2015, scientists have found evidence of a 12-mile-wide reservoir of briny water beneath the South Polar layered deposits. This and other exciting discoveries deserve to be built upon, explored, and studied to their full potential. That's why we're gathered here today, to build upon the framework that was established in the NASA Transition Authorization Act of 2017, and to make progress in ensuring that our nation's exploration priorities are being met so that we can push humans further than they've ever gone before. Somewhere in a classroom today, in Texas, or Florida, or Massachusetts, sits a child who may one day become the first American to reach the surface of the red planet. It's our responsibility to ensure that we have a national space program that can help turn that dream into a reality. With that, I'll recognize the ranking member of our subcommittee, Senator Markey.
Thank you. By the way, there was already a school child from Massachusetts, from Ringe Tech, Matt Damon. He was already the first person to step foot on
and one of these days, I hope we bring him
Mars,
back.
so we're very proud of our high school and grammar school educational process. And, so next year, we celebrate the 50th anniversary of the Apollo 11 lunar landing. For nearly 50 years, we have known that our sky is not a ceiling. We have known that no mission is beyond the power of American ingenuity. And we have transferred our knowledge into transforming galactic astronomy into earthly technology, building better rockets, and even researching better designs for faucets and for tires. We have set our sights further beyond the moon and onto Mars. For nearly 50 years, NASA has stood for new adventures in space abound. And in the 1960s, NASA's first successful Mars mission showed us the first up-close images of the cratered Martian surface. Only last month, the Curiosity rover found ancient organic molecules on the Martian surface. And our next adventure will be the launch of the Mars 2020 rover, which will look for signs that Mars was once habitable billions of years ago. Just today, we learned that the Italian Space Agency found a lake of liquid water beneath the southern polar ice cap of Mars. As Ray Bradbury writes in the Martian Chronicles, quote, "It is good to renew one's wonder," said the philosopher. "Space travel has again made children of us all." All of these missions have not only inspired wonder and raised questions, they have also prepared us for mankind's next great achievement in space, putting humans on the surface of Mars. As a nation, we've dreamed of putting humans on Mars since the year we put boots on the moon. NASA has made great strides. The Space Launch System, rocket, and Orion spacecraft are in development as we speak. Critical scientific experiments are being carried out on the International Space Station in low Earth orbit, including technology demonstrations from one of our witnesses, Dr. Dava Newman of the Massachusetts Institute of Technology, who will testify here later. However, NASA faces many setbacks, some self-inflicted. NASA was supposed to deliver a human exploration roadmap by December of 2017, but still has not provided it to Congress. Without this step-by-step plan, we will be flying blind as to what comes next in our quest to have humans reach the red planet. This administration also has not made its own priorities clear when it comes to human space flight. In December of last year, President Trump stated, quote, "Beginning with missions beyond low Earth orbit, the United States will lead the return of humans to the moon for long-term exploration and utilization, followed by human missions to Mars and other destinations." This sounds less like a plan to go boldly where no human has gone before, but rather a plan to return to where we have already been. We need to help NASA lift its gaze past the moon and understand how the work we do in space closer to Earth will serve us in our quest for Mars. NASA and Congress will have to make tough decisions when it comes to funding. We have heard testimony in the subcommittee that the International Space Station is a vital platform on which astronauts perform essential scientific studies. But we have to make the math add up. How can we fund the space station while also funding a human spaceflight program that gets us to the Martian surface? How can we balance the push for new discoveries on Mars with the continued importance of performing science in the low Earth and other orbits? These are the questions we have to ask ourselves as we move forward a NASA authorization bill that lays out a trajectory for this agency. I know that my colleagues and I look forward to that day when we bid farewell and Godspeed to our best and brightest explorers and scientists as they journey to the red planet of our solar system, going where none have gone before. It has been nearly half a century since that greatest of all human achievements, Apollo 11. We must ensure that the extraordinary space race is not merely a sprint, but an interplanetary marathon. We thank all the witnesses today, and I thank you, Mr. Chairman, for this very important hearing.
Thank you, Senator Markey. We now recognize the ranking member of the full committee, Senator Nelson.
I want to say that you boys are getting pretty good with your visionary rhetoric. I could close my eyes, Senator Markey, listening to that lilting Bostonian accent, and I could think back to the time when it was a Bostonian that set us off on this journey, and a Bostonian that allowed that journey because he had the vision to say we're going to the moon and back safely within the decade, that allowed Dr. Buzz Aldrin, who is with us in the front row, along with Neil Armstrong, to set foot on that body 250,000 miles. So thank you for your soaring rhetoric. To bring it right back down here, there's an excitement that's going on. We're about ready to start having Americans crawl into American spacecraft and lift off from the Cape, and that's right around the corner. And when that happens, what we're going to see is this nation suddenly gripped and captivated in its imagination that we are back in spaceflight, even though we've been there. And 6 humans are up there in the space station right now. And by the way, thank you, Mr. Chairman, for joining me and others as we are going to keep the space station alive instead of this nonsense that they're going to shut it down in a few years and lose that $100 billion investment. We've got to keep it operating safely and productively. We need to get our new crewed vehicles across the finish line, get them launched, first test flight, hopefully by the end of this year, and then the first human flights early next year. We need to finish building SLS, Orion, and the infrastructure on the Cape to launch all of this new and exciting activity. And we need to keep up on our progress in NASA's world-leading science and aeronautics, the first A in NASA. And we need to prioritize the kinds of technology investments that will make a mission to Mars safer, more productive, and more affordable. And for your constituent, Matt Damon, by the way, in the book and the movie, he was propelled there by a technology that was developed by MIT graduate, one of 2 astronauts that have flown the most, Dr. Franklin Chang Diaz, who is still working on that plasma rocket. This year's budget request from NASA proposed some new programs, including efforts to develop a range of small, medium, and larger lunar landers, and ultimately leading toward a human lunar lander. And the request also included development of a human-tended gateway to orbit. Now, the good thing about a gateway is lunar orbit would become what Earth orbit used to be in the assembling of spacecraft and the launch point from which commercial ventures could go to the surface of the moon. We've got to watch our expenditures for NASA about going down to the moon because we don't want to rob the NASA budget on what is the goal. And the goal is to get to Mars with humans. The Gateway was previously portrayed by NASA leadership as a test vehicle for deep space transport to take us to Mars. But notably absent from this request is any mention of the Mars transport vehicle. And we better watch out with that if we want to stay on the course for Mars. And so as we review these proposals, we need to think about 2 important points. Do these missions help us achieve our goal of getting humans to Mars? And second, show me the money. The Augustine Commission found NASA needed an increase of a few $billions a year, and increases that will at least keep pace with inflation to do any sort of a meaningful exploration program. And a couple of years later, the National Academies found that if we only get increases in NASA's budget equivalent to inflation, forget the scenario of going to Mars in the decade of the 2030s. It'd take us till 2050. I don't think we want to wait that long, because international and private partnerships, if employed smartly, could certainly help us improve the affordability of our exploration program. And in recent years, Congress has given NASA some pretty healthy budget increases. I know we're going to continue to push for those increases, but we need a plan that keeps everyone, industry, Congress, our international partners, the men and women of NASA, all pulling in the harness in the same direction. Our 2017 NASA authorization bill, Senator Cruz, required NASA to define and deliver to Congress a step-by-step plan for reaching Mars. We don't have this roadmap yet. It's 7 months overdue. But anyway, NASA is moving on major acquisitions like the development of a large lunar lander. What gives? Let's see the program for going to Mars and how all of this other fits in. We need to make sure we're making smart choices about the priorities. We don't have the luxury of having near 5% of the federal budget going to NASA as it was in the time of astronauts Armstrong and Aldrin. We need to make sure that we understand what NASA needs to do and what is being asked of them. So thank you, Mr. Chairman, for calling this hearing.
Thank you, Senator Nelson. Let me thank Senator Nelson and Senator Markey both for your strong leadership in ensuring and continuing the bipartisan support for NASA and our space exploration mission. I guess I have to apologize to the witnesses that apparently you've been overshadowed by a mystery witness, Matt Damon. And you know, I would note that in his journey to Mars, Mr. Damon demonstrated the ability to grow potatoes in human excrement. And I would note likewise, there is no greater repository of expertise in that biofuels than the United States Congress. So with that...
But may I just say that we are the most Irish city in the United States, and we're very good at growing potatoes, okay? It's something that we learned in the new world, and to Senator Nelson, I did not use the full accent in talking about the future and leaving behind the past. I decided to use the Malden version of that accent, but nonetheless, the vision of President Kennedy still lives.
With that, I'm happy to introduce our distinguished witnesses today. Our first witness is Dr. Peggy Whitson, who is a retired NASA astronaut and a biochemist. A native of Iowa, Dr. Whitson has had a career at NASA which includes becoming the first woman to serve as their astronaut corps chief and the first female commander of the International Space Station. Dr. Whitson has completed 3 long-duration missions to the ISS, which include 10 spacewalks, and setting the record for the most time in space by a U.S. astronaut at 665 days. Prior to being selected to serve as an astronaut, Dr. Whitson received her PhD in biochemistry from Rice University, my mother's alma mater, and worked as a research biochemist in the biomedical operations and research branch at NASA's Johnson Space Center. Our second witness is Mr. Tory Bruno, who is the President and Chief Executive for United Launch Alliance, which utilizes the Atlas and Delta rocket families and has achieved more than 120 consecutive launches since 2006. In his role as CEO, Mr. Bruno serves as the principal strategic leader of the organization and oversees all business management and operations while managing a nationwide team of nearly 2,500 employees. Prior to joining ULA, Mr. Bruno served as the Vice President and General Manager of Lockheed Martin's Strategic and Missile Defense Systems. Mr. Bruno holds a bachelor's degree in mechanical engineering from the California Polytechnic State University. Our next witness is Mr. Chris Carberry, who is the CEO and co-founder of Explore Mars, Inc., a nonprofit created to advance the goal of sending humans to Mars within the next 2 decades. Prior to joining Explore Mars, Mr. Carberry served as the executive director to the Mars Society. In recent years, Mr. Carberry has led the successful international conferences, including the ISS and Mars Conference in Washington, D.C., and Strasbourg, France. Prior to his space career, Mr. Carberry worked as an archivist of modern political papers and was a research assistant for numerous best-selling biographers. And finally, Dr. Dava Newman currently serves as the Apollo Program Professor for Aeronautics and Astronautics at the Harvard-MIT Division of Health Sciences and Technology. Dr. Newman's research includes advanced spacesuit design, dynamics and control of astronaut motion, mission analysis, and engineer systems design and policy analysis. From May 2015 to January 2017, Dr. Newman served as the Deputy Administrator of NASA. In her role as Deputy Administrator, Dr. Newman was responsible for providing overall leadership, planning, and policy direction for NASA. Dr. Newman received her PhD from MIT in aerospace biomedical engineering. And with that, Dr. Whitson, you may begin.
Mr. Chairman and members of the committee, I'm really pleased to be here today to chat with you about America's plans for deep space exploration, including missions to Mars. Within my 30 years of experience at NASA, I have watched our exploration goals evolve, becoming a global effort now and advancing humanity's presence in continued exploration of space. The future exploration plan is complex and necessarily integrated across commercial and international lines, as was recommended by some of the committee members. And I also agree that that is as it should be. While the idea of expanding our horizons is a simple one, the actual design solutions, the implementation of a plan, adapting when problems invariably strike, and pressing forward in spite of obstacles is the embodiment of exploration. Sustainability is going to be a key in our success in our future exploration. So learning from each successive advancement will give us an enduring platform for growth. And although space is the goal, the benefits of the end results will be here, much closer to home, spurring additional commercial activity in low Earth orbit and expanding our knowledge and opportunities here on Earth as we search for and find those necessary and innovative solutions that we're going to need for those next exploration steps. For example, our technologies that we've developed on board the International Space Station on water purification and recycling, they're a critical component for our continued exploration to the Moon and Mars. But they also have huge potential here on Earth in areas where clean water is limited, and now maybe in the lake it might be handy there too. A United States-led exploration of humans to the Moon via the Lunar Orbiting Platform Gateway will allow for sustainable exploration and scientific utilization, as well as the practical testing of new partial gravity technologies and operations methods, solar electric propulsion techniques, that are all critical components for our subsequent missions to Mars. Mr. Chairman, in my 665 days in space, I've personally experienced overcoming seemingly impossible obstacles, learning resourcefulness imposed by the unique and harsh environment of space, And I've seen some of the best of what human beings have to offer, and been lucky enough to be a part of a world community that has striven to each new level of competence, including the advancement of commercial capabilities. So I recommend we take the lessons that we've learned on the International Space Station, understanding that it is a microcosm of what we need to happen on a much larger scale for our future exploration activities. I believe that developing a flexible deep space infrastructure to support a steady cadence of increasingly complex missions will strengthen American leadership in our quest to go where no person has gone before. By leveraging commercial and international collaborations, we will ensure that the best minds in the world are working toward our exploration objectives, and with NASA's leadership, a logical approach to expand our reach and sustainability of human space exploration will continue, building on the station and increasing with our capabilities in our new heavy lift SLS and Crew Orion capsule and the exploration ground systems. These strategies hold the highest likelihood of success and promise to extend technical and scientific benefits to all of mankind, humankind. On a personal note, thinking back on my rural Iowa farm beginnings and seemingly impossible dreams, I want our exploration to fire the imaginations of all people. There really are no boundaries. So I'd be pleased to respond to any questions from you, Mr. Chairman, and the committee.
Thank you, Dr. Whitson. Mr. Bruno.
Thank you. Chairman Cruz, Ranking Member Markey, Ranking Member Nelson, and members of the subcommittee. Oh, there we go. Thank you for the opportunity to appear today on a subject of profound importance to our nation and the world, putting American boots on Mars. I am privileged to represent the talented team at ULA who have joined NASA in exploring missions that lay the foundation for future landings by Americans on the Red Planet. ULA is proud to be playing its part in extending the presence of humanity to Mars. Since the company's formation in 2006, ULA has successfully launched every United States mission to the Red Planet. Our rockets have gone to Mars 18 times. ULA's Atlas V and Delta rockets have an unmatched record of 100% launch success. Our rockets have launched missions to every planet in our solar system and beyond. In May, we launched the Mars InSight lander, the first mission to Mars from California. In a few weeks, ULA will launch the Parker Solar Probe, a mission which will study the sun and unlock new understanding of our nearest star and its impact on our planet and the environment between here and Mars. Clearly, Mars exploration is a vast undertaking requiring a space industrial base of enormous breadth and depth, and ULA is critical to stabilizing that workforce. Our company is comprised of employees at facilities in Denver, Pueblo, Decatur, Harlingen, Cape Canaveral, and Vandenberg. ULA also partners with more than 2,700 suppliers from across the country. By working with large and small suppliers, ULA plays a critical role in ensuring a stable space industrial base. ULA recently entered into a long-term strategic partnership with Aerojet Rocketdyne, selecting the flight-proven RL-10 engine to power our Vulcan Centaur upper stage. We have also entered into strategic partnerships with several other companies, such as L3 for avionics and Spincraft for fuel tank domes. All of these companies and many others supply critical components to NASA's Space Launch System, which will be the world's most powerful rocket, providing super heavy lift for the Orion capsule and human missions to Mars and other deep space destinations. With ULA as a core customer, these supplier companies are able to provide components to NASA and their SLS and Orion partners more affordably and demonstrate reliability in their systems with dozens of flights aboard Atlas, Delta, and soon Vulcan Centaur. The nation's launch industrial base is critical to America's status as the premier spacefaring nation, as well as to our national security and economic well-being. With domestic and foreign competition on the rise, and a launch forecast that may be flat or even declining, it is crucial Congress take steps in any space legislation to stabilize our competitive industrial base and prevent U.S. taxpayer-funded payloads from being sent overseas to be launched on foreign vehicles from foreign launch pads. NASA must lead humanity's return to the moon and travel to Mars, and SLS and Orion are going to get us there. We appreciate the strength and enduring nature of congressional support for these programs. I would also like to applaud the current administration's emphasis on returning astronauts to the moon. Together, Congress, the administration, and industry can chart a path forward that uses the lunar vicinity as a test bed and jumping off point to Mars. That is where ULA will play a key role, providing cargo and scientific transportation services for commercial activities in cislunar space to complement the core human spaceflight and large payloads provided by SLS and Orion. At ULA, we have already taken the first steps in achieving this goal. ULA's cislunar 1000 roadmap envisions self-sustaining community of 1,000 people supported by some 200 companies in the space between Earth and the Moon. Developing the valuable resources that are abundant on near-Earth asteroids and the lunar surface will provide a foundation for this new econosphere. The ingenuity of America's private sector, together with NASA, will be required to extend human presence beyond Earth. Thank you again for inviting me to be here before you today. I look forward to your questions.
Thank you, Mr. Bruner. Mr. Carberry.
Thank you, Chairman Cruz, Ranking Member Nelson, and the subcommittee for the opportunity to testify at today's hearing. Honored to be here to discuss how the United States should lead humanity's efforts to land humans on Mars. Next July, we're going to celebrate the 50th anniversary of the Apollo moon landings. Today, we're at an exciting watershed moment, well-positioned to continue where the Apollo program left off and poised to land Americans on the surface of Mars in the 2030s. To further this goal, teams of scientists and engineers have participated in a series of workshops to develop scenarios for achievable Mars missions. These workshops, known as the Achieving Mars Workshops, are organized by Explore Mars in partnership with the American Astronautical Society. These Mars scenarios have 4 essential characteristics. 1, they're affordable. 2, they're achievable without technological miracles. 3, they're sustainable in coordination with our partners. And 4, they achieve major and long-standing scientific goals. The most recent workshop was largely motivated by the passage of the NASA Transportation Authorization Act of 2017, which states that NASA should take steps to quote, leading to human habitation on the surface of Mars. The act goes on to say that NASA should contract outside organizations to, quote, study the feasibility of the launch of a human spaceflight mission to Mars in 2033. If this deadline is to be achieved, we can't allow ourselves to postpone critical decisions. Otherwise, we'll have little hope of seeing American boots on the ground in the 2030s. Fortunately, numerous feasible concepts to land humans on Mars have been proposed by NASA, industry, and commercial players and other stakeholders. And our workshops have revealed significant commonalities among most of these scenarios. We've outlined 3 architectures that span the range of likely options for human missions to Mars. The first scenario involves sortie-like missions with a 2-week stay on the Martian surface and is analogous to the Apollo program. The second concept is a semi-permanent base or field camp with a 1.5-year stay on the Martian surface and is analogous to early Antarctic exploration. And the third concept is sustained permanent habitation analogous to current Antarctic exploration, but with setting the stage for potential settlements. And the full report for that workshop will be available in the next 2 weeks. These workshops also found that any plan to send humans to Mars should acknowledge that science precursor missions in the 2020s are essential to human exploration in the 2030s. The Mars 2020 rover is the last robotic mission the United States currently has funded. This must not be the end of our Mars robotic program. We need new reconnaissance capabilities as well as deep space communications, and if we plan to do a sample return mission, let's consider a heavy sample return mission that not only can bring back a significant number or amount of Mars samples, but can also be an intermediate test for entry, descent, and landing capabilities and other key technologies. Also, precursors to the moon should be designed and executed in a manner that will have a clear path to Mars and stimulate commercial and international participation. And as plans for the moon and Mars proceed, experts should determine which capabilities are vital for both the moon and Mars. The United States is well positioned to move ahead now. NASA and its industry partners are developing launch and crew capabilities well beyond existing systems, and commercial entities are advancing impressive technologies. There's also strong support for human spaceflight, particularly Mars, amongst the public. This strength and this support becomes clearer when the public is given precise information. For example, as shown in the 2013 Mars Generation Poll, when informed that NASA accounts for less than 0.5% of the federal budget, the public tends to overwhelmingly support ambitious plans for space exploration. So, with bipartisan support in Congress, with unwavering public support, and clear support from the current and past administrations, many of us wonder why our nation seems unable to commit decision to finally enable human missions to Mars. We don't want to squander this broad support, and in 20 years, find ourselves looking back to realize we were unable to return to the surface of the moon or send humans to Mars. Mr. Chairman and members of the committee, I'd like to thank you for taking the time to hold this hearing. I conclude by saying that while we should never be reckless with the lives of our astronauts, we need to take calculated risks and be bold, as we were in the 1960s, to achieve something truly extraordinary for the United States and the world. We are well past due for the next giant leap. Thank you.
Thank you, Mr. Carberry. Dr. Newman.
Thank you, Chairman Cruz, Senators Nelson, Markey, Peters, and Sullivan. It's my great honor to be here with you today. Putting humans on Mars has been my lifelong passion my entire research career. So I'm very delighted to talk to you, and I was honored to serve as NASA's Deputy Administrator previously. In the past 40 years, we've learned an impressive amount about our sister planet Mars. Thanks to NASA's scientific robotic missions from Viking through Curiosity, we have more information on Mars than any other planet, excluding our own. These missions have brought back amazing images, majestic, alien landscapes. It's mentioned today, the new discovery today. Every day I get to read this stuff. A lake underneath the surface of Mars, and previously the organic molecules. So it just keeps getting better all the time, every day. So really, what we're here to talk about then is priorities and investments. Scientific spacecraft and rovers, they're going to continue to make great discoveries and answer the three fundamental questions of all of exploration. Are we alone? Are there other habitable planets? And what about life? The evidence is mounting in other planets. So landing that first mission to Mars, that human mission, the women and men, we're going to surpass 50 years of our rovers. I love our rovers. They're great. But we've only gone 75 kilometers. So when we get that first boots on Mars, the first mission, we're going to surpass the last 50 years. That's how exciting it is to me to get humans to Mars and for discovery and scientific purposes. Nothing inspires a nation more. Our future generations, my students, our students, I call them the Mars generation, more than human spaceflight. Putting humans on Mars has been my dream as long as I can remember. And I was inspired by Apollo 11 because Buzz, thank you, inspired a young girl from Montana to think everything's possible. We don't have limits if we really put our minds to it. But dreams and willpower, they're not sufficient. We already have some of the brightest scientists, engineers, and technologists putting our inventiveness and persistence to the boots on Mars journey. We've had great bipartisan support from congressional leadership, thank you, and across administrations. We need to build on those foundations with a clear strategy and commitments for significant long-term funding. Prioritizing among NASA's many important missions is never easy, and in Congress you have hard decisions to make. We spend $4 billion annually for our low Earth orbit missions, where we do really important work. I was able to fly technology demonstrators in 2015 and 2017 on suits for astronauts. But from an exploration point of view and the desire to push humanity beyond what we even think is possible, we've been stuck in low Earth orbit for too long. We need to rethink the funding portfolio and timely investments to succeed in getting to the moon and onward to Mars. Strategically, getting to Mars is figuring out the optimal roles for NASA, private, commercial space ventures, and our international partners. Within NASA, we need to better integrate science, space technology, and human exploration portfolios. I recommend a synergistic Mars program office across all three with the necessary budget. My view of the best pathway to Mars breaks the strategy into 3 phases. Currently, phase 1 on International Space Station. Phase 2, getting back to the moon briefly, demonstrate the technologies that we need to sustain our astronauts beyond low Earth orbit. Namely, they've been talked about a little bit before, heavy lift launch capability, our solar electric propulsion, surface habitats, our life support systems and mobility systems. So soon we'll fly to Earth-Moon orbit and land on the moon. We need to evaluate the feasibility, cost, schedule, and investment portfolio, and then make the decision to stay the course, no dead-end elements. Phase 3 is self-sufficient travel to Mars. Explorers will be months away from home, completely autonomous, no instant communications with Earth. Mars is hard and it's really far away. So we'll rely on our technology investments of the 2020s in our advanced propulsion, in our smart habitats, in our advanced human-machine autonomy, and novel radiation protection. All of those investments now and in the 2020s will pay off to get humans to Mars. It's going to be a completely self-supporting journey to realize this seamless interoperability between our humans and our machines. It's both. It's always humans and our machines to make the big scientific breakthroughs. It'll take a focused strategy and technology development to implement phase 2, getting back to the moon, and shortly thereafter, phase 3, to assure that U.S. will lead human Mars exploration. At MIT, myself and my students are working on some of these challenges. We investigate astronaut performance and reduce gravity, and design suits and engineer solutions to keep them safe and healthy. There's also Earth applications for everything we do. Specifically, in my case, to help humans walk. Think about how we can help with cerebral palsy, all those dual-use technologies, the investment here on Earth. So those investments, though, in the universities, they're very low technology readiness levels. So that's why it's crucial that we integrate science, space technology as central parts of the NASA Mars strategy. Increase the funding, keep it stable, develop a NASA portfolio that greatly furthers synergies among science, technology, and human exploration. This comprehensive phase plan, with the right leadership and coalition, will send us beyond low Earth orbit to the moon and to Mars, put humans on Mars in the 2030s. Thank you very much.
Thank you very much, and thank you to each of you, the witnesses, for your testimony. Let me start out with a question to the panel. Why Mars? Why should the American people care if we put a human being on the surface of Mars?
Well, I think we have a lot to learn about life and how it might happen and occur in other places. And I think one key aspect of exploration, if you look at the philosophical part of exploration, is learning about life and where we've come from. But I think, the big thing that benefits of exploration maybe are not so much those philosophical ones, even though that's what drives some of us. I think it's the technological advancements. Doing these difficult things is going to improve our capability as a country, as a nation, as a world on solving problems here on Earth. And increasing technology, having people interested in the sciences, studying more and learning more things in the sciences is going to be a benefit here on Earth.
I agree with everything my colleague has said. I'd just like to add that when you want to establish a fundamental scientific understanding of a complex system like our own planet, it is crucial to be able to study similar, in this case, celestial bodies in a different state of their evolution. And Mars uniquely offers us that opportunity to have more than one data point in a different state than our own planet is in today.
It's interesting. My organization actually has a whole program on this very question. We released a document about a year ago where we had about a dozen different individuals from different disciplines. We had Hollywood actors, we had scientists, we had science fiction writers, all and STEM educators, just every imaginable discipline, explaining why we did. And this is one of the biggest questions, why I think the whole space community sometimes doesn't answer the question well, because there are so many good answers. When we went to the moon, really there was one primary answer: to beat the Soviet Union. It was easy to articulate, let's beat the Soviets. Today we have so many more and so many better reasons. The inspirational value. If you go around speaking to kids around the country, you realize they're really inspired. The technologies that will be required for it. Plus, of all the places that humans can go in the solar system, Mars is best suited for humanity. As the discoveries today of the liquid water below the surface of Mars will show, we can live off the land on Mars. While there are resources on the moon, they're not nearly as, abundant, and there's no atmosphere there. So Mars is really the best option for sending humans for sustainability that we can achieve anytime in the near future.
Agree with all my colleagues. But Mars and Earth, 4.5 billion years old each, sister planets. So Mars was probably habitable, warm, wonderful. And then probably 3.5 billion years ago, something went terribly wrong. Why is that so important? It teaches us about Earth because it teaches us about life. So it's a fundamental question about life, and we follow the water. So we're going to follow that water we just found today right down into the subsurface because you look for those amino acids. Those amino acids have been spewed all over by comet sensors. They're all over the universe. So we're looking for life. So the search for life has been mentioned. It's the closest, not too close, closest place to go, best place to go. We will find this answer about life, other places, past or present in the universe. That will fundamentally rewrite all of our scientific textbooks. And I just can't think of anything better to do.
In your judgment, what are the biggest scientific and technical hurdles that stand between us and landing safely on Mars? And are we on trajectory to clear those hurdles and get to Mars and back safely by the 2030s?
So I'll go first. From a rocket scientist point of view, it's actually very difficult to go to Mars. And I place those challenges sort of into two buckets. One is simply the trip. The orbital mechanics of traveling to Mars is a challenge. The other are the human factors, or the safety aspects of going to Mars, because it is a very long, deep space transit. So if I start with the first aspect, just to give you a feel for it, our two planets are always in relative motion. And the geometry of the Mars orbit is especially challenging because not only is Mars going around the sun at only half the rate that the Earth is, it's also a very eccentric orbit. It's highly elliptical. And so the distance between our two planets can be as small as a gigantic 35 million miles or as large as 250 million miles. And the only times we can really practically go to Mars is when the Earth is catching up and about to surpass Mars, and at that point, that's really our only launch window, where we send a spacecraft to sort of tangentially drift off and later intercept with the Martian orbit and then do that rendezvous. Those opportunities only come around once every 2 years because of the relative motions of our planets. The orbital accuracy required to achieve that defies sort of human imagination. It's hard to relate to what we truly have to achieve. So I did a little quick math last night to try and scale all that down so it would fit on the Earth so that we could sort of relate to it a little bit better. And the way it works out is if we place this on Earth, scaled down, it's much like hitting a hole-in-one, for those of you who are golfers, out at California's beautiful Pebble Beach, teeing off from Paris while standing on a moving pickup truck. That's a pretty difficult problem. You're sending this spacecraft on a fixed trajectory to travel as much as 300 million miles way back at Earth. That's when you let it go and it heads off. So the orbital mechanics piece is very, very difficult. The next challenge we run into is the transit time in the environments that our Mars astronauts will be exposed to. Because this is deep space travel, they will be experiencing radiation environments that are 4 times more severe than what we see on the International Space Station, which is largely still protected by the Earth's magnetosphere. Because of the extreme duration of the mission, now we can get to Mars on the right 2-year cycle, theoretically as fast as 3 months. But most practical missions are really going to take more like 6 to 8 months. So because of that duration, our astronauts that go to Mars and conduct a mission and come back are going to see at least 100 times, probably more than 100 times, the total radiation exposure that Apollo astronauts experienced going to and from the moon. And so it's going to be absolutely vital that we developed ultra-lightweight shielding materials and procedures and CONOPS that will minimize the exposure of our astronauts to that environment. We know only some of the health effects associated with that kind of radiation exposure, and if they're not protected, they're pretty scary. We understand there will be significantly increased risk of cancer, the potential for nerve damage, cognitive impairment, and even cataracts. And so we cannot tolerate that. We have to keep our astronauts safe and within reasonable risk limits on that trip, which is also why I believe the moon, in a way, is on the way to Mars, because it affords us a platform to do that research, develop these technologies, qualify them nearer to home, 3 to 6 days from home, before we commit that trip that's going to take at least a year.
Thank you. Senator Markey. Senator Nelson.
Thank you, Mr. Chairman, and thank you, Mr. Bruno. That was a most articulate explanation and is in response to a former statement by Mr. Carberry that they were going to send a quick expedition there for 2 weeks on the surface. That's assuming that you've got the planets aligned, that you can get there, and therefore that begs the question, don't we have to have a faster propulsion to get us there? So Drs. Newman and Whitson, how much of a priority should NASA place on the space propulsion technologies? And from the obvious, other than that, what is the benefit of shortening the time to get to Mars?
Well, probably the biggest benefit of shortening the time is reduced radiation risk. It's easiest to protect the crew from radiation risk by not exposing them for as long a periods of time. So that decreases it. And then once you get on Mars, you could bury your habitat and provide some protection that way once you got there. But so I do think getting there faster is a big part of the solution. And I do think that there will still be risk, radiation risk. So I think developing other alternative medical or biomedical type solutions might also need to be necessary as well, just to have that as a backup. But I do think getting there faster will help, for sure.
I agree. I'd love to shorten the time by half. So the investments, again, the technology investments in advanced propulsion, I think we can still make it even if we use conventional, chemical rockets. One technology we haven't talked about is entry, descent, and landing. It's critically important. Right now, today, we know how to land 1 to 2 metric tons. It's fantastic what we do with Curiosity rover, Mars 2020 coming up. But truthfully, we know how to land 1 to 2 metric tons. So your human mission, start the baseline wherever you want. 20 metric tons, 40, I believe in. How about 5 metric tons, 10 metric tons? How about modular designs? How about new kind of architectures? But that is a step change. So that's a limitation right now in our understanding, but that's why we're studying it. Agree with the propulsion. The radiation, there's some great research going on. I'm optimistic. Give us 10 years. Sure, we need shielding, better materials. We're on it, but we've got to look at biology as well. This will help our few Martian astronauts, but that will fundamentally help cancer research here on Earth. So if you want to talk about synergies, and it's happening, and I think within the decade too. So really looking deep into the biology and the genetics of this is going to help protect our astronauts, but as well as could be fundamental for life here on Earth.
So, Mr. Bruno, what is the importance to industry that NASA have a stable plan to get to Mars instead of a herky-jerky kind of approach?
Yeah, stability in terms of a clear plan and direction, set of priorities, and funding stability is absolutely vital. In industry, if you don't have the work for your people to do, they don't stay on the team. They scatter, and they go to other industries, they go to other activities, and human capital is everything to this mission. You know, the physical things are important, but those are the easiest things to come by. Launch pads, tooling, factory, that's the most replaceable. Know-how, expertise, and experience, that's very perishable, and that is the most important thing. So it is absolutely the number one priority from an industrial point of view.
Dr. Whitson, other than the exposure to radiation, what are we finding out by your personal experience of many days in near zero G that we're going to have to overcome to go on a mission to Mars?
Well, in engineering terms, I'm the fleet leader right now. I've got the most revolutions, the most radiation. But I do feel that we have come a long ways. We've learned a lot of things. We still are learning some things. You know, we're able to protect bone mass, which is a big deal. We don't know for sure if it's all going to be the same bone quality because it's always constantly being remodeled. So we're still doing more detailed studies on that. But we're testing different types of drugs because we have a platform where we can test those new drugs and understand them. And easily by the time we start sending people, we will have complete solutions for those, I think, and we will be ready. I think really the biggest hurdle right now, I think, is radiation. And, you know, we do have some changes in the vision, but I think we're getting a handle on even those now as well. So I think we will be ready. And we do have a roadmap of different types of investigations and answers that we need for the Mars missions. And I'm confident that we'll get there with platforms like what we have on the ISS and on the future Gateway. That could also be an excellent platform for some further research as we extend.
Thank you. Thanks. Thanks, Eddie.
Thank you. Senator Markey.
Thank you, Mr. Chairman. Dr. Newman, you spoke in your opening statement about the importance of human exploration rather than relying upon robots alone. Why is that important? Why is human exploration so important in substitution for robots or other technologies, given every other industry moving to automation?
So it's really our humans and robots and our machines together. We really are now in a world versus global exploration and as humans and machines. Mars is so far away, it's the communications. So we have to change we call them CONOPS, mission operations. Our humans have to be completely autonomous. We mentioned before, just the inspiration, lifting everyone up. Let's just do the hardest thing that is possible to do because we know we can do it, and that'll raise everybody up. I've spent my whole career in STEM education. I call it STEAM now because I want to bring in the arts. I bring in the makers because every little girl and boy I talk to say, "You're in it." You want to get humans to Mars. It inspires every single one of them. The human capability, when we get to Mars, we will surpass what we've done for 50 years with rovers. I mean, I'm a roboticist myself, but we've only covered, these are slow and we only go an inch at a time. So we're really mobile, we're really good. We are going there to explore. So you can just cover so much terrain. And Apollo made a huge difference when we gave the rover. So the humans on their machines in that rover, and we just doubled and tripled our range of exploration. So I really do see it as it's time for humans. We'll keep doing the precursor robotic missions, but when we really get there, if we haven't found life already, I think we'd find it very quickly then with human and robotic missions together in synergy. Thank you.
No,
If I could add one thought to Dr. Newman's remarks. Robots are really, really good at doing one thing. We program them to do one thing, they're great at it, they can be better than a human being at that. What human beings are good at is doing many things in many unanticipated tasks. There's absolutely no replacement for a Buzz Aldrin boots on the ground when you get to Mars and you find the conditions are not exactly as you anticipated, or you discover something you want to investigate further. A person can do that. We have to send another robot from Earth if we want to do that.
Yeah, so thank you, Buzz Aldrin, for everything you do. We need, yeah, and so I agree with you. We need boots on Mars, not just bots on Mars. We need to ensure that we do both, but the boots on Mars is the key. Can you talk a little bit about the benefits to humanity of going to Mars? What do you see as the derivative benefits, Dr. Newman?
Thank you. I think it's globally hard to really, you can't put a price tag, you can't put importance on how Apollo fundamentally changed all of us. I am sure that I'm here today because I was a young girl watching Apollo 11. I mean, it was so inspirational. Again, it just had everything, the best of humanity. So that's how I look at the Mars mission now. We get humans there with all of our great science. It'll lift us all up. It will open up the eyes and the doors. So I really do see it as global cooperation and lifting up humanity. Who knows what we can do? We have some real challenges. We have some real scientific and technology challenges here on Earth. And I like the point that was made perhaps too. We need more of an N of one. We just have Earth now. Once we have a whole solar system out there. I'll tell you a lot about what's happening on Venus and Mars. So again, just putting that all together and just saying the solar system is ours. We do it together. We share that. What a great day today with this science discovery. We're all going to take credit for that, right? It's Italian lead investigators, but we're all in this together because guess what? NASA's funded most of that science to make that happen. So that's how I look at it. It really is for all of us. It's something that is completely inclusive, and it's for everyone. And it just helps us, raise our game.
So
I'd like to actually comment on this as well.
Just give me 1 second. Mr. Bruno, can you comment on a second on what opportunities exist in cislunar space that could benefit us down here?
Cislunar space promises the potential of a post-scarcity human future. It's a complete paradigm change for our civilization and for what it means to be a human being. Today we think on Earth about fixed resources in a world in which there is ever more scarcity as we go forward. But when we look out into cislunar space, just a scant week's journey from where we sit today, there are such resources in such abundance that it truly defies human imagination. There are 1,000 years of total global production of industrial metals just in the asteroids between here and the moon. There's more precious metals than have ever been mined in the history of humankind. So when it is practical and affordable to access those resources, we're looking at a human future that is completely different than what we have seen before.
And Mr. Carberry, if I may, international cooperation, how important is that?
Extremely important. We've been actually doing a number of programs on this. We did a partnership with the UAE recently. It's been one of our primary objectives to try to really make sure human exploration of Mars is international. It should be led by the United States, but our international partners want us to lead. They continually say at various events that they will follow along if they can see that we are actually leading the path, but they have concerns that we keep changing directions, or they're not sure that we're going to stick with the direction. So I think it's extremely important not only to build that sustainability, but also to offset some of the budgets as well. I think we absolutely need international participation with Mars missions.
Thank you. Thank you, Mr. Chairman.
Thank you. Senator Peters.
Thank you, Mr. Chairman, ranking member for this committee, a fascinating committee that, and certainly appreciate the testimony. I want to pick up on Senator Markey's question about international cooperation, especially in terms of how we pay for all of this. I'm a huge booster of this. I think we've got to move forward. I share, Dr. Whitson, with your philosophical dreams as well. I think that's an important part of it, but also I'm a dollars and cents guys, and I have to go back to my constituents and make the case as to why these investments are important, and also how we can do this in an efficient way. And I think most taxpayers will say, why would the United States just government and taxpayers do this all by ourselves? notwithstanding all the wonderful benefits, which I all agree. I'm not arguing against any of those benefits. So my questions are related to how do we find those partners? Mr. Carberry, you mentioned the international partners, but before I go to that, it seems to me that when we think about the advantages of this journey, beyond the philosophical ones, it is technological advancements. We know what happened in the Apollo program and all of the spin-offs that were there that benefited our society immensely. Because of the extreme and difficult technological challenges for Mars, I suspect those advancements will be even greater and will be at some sort of exponential amount of that. But I want to get your sense, where is it possible to have private industry partners? Because often with a lot of this technology, it's not happening within government. It's artificial intelligence is not happening to the same extent within government labs as it is in the private sector, which is moving very rapidly. I'm from Michigan. Autonomy, self-driving vehicles and autonomous systems are moving incredibly rapidly in the private sector as well. What sort of opportunities do you think we have for us, NASA, to partner with private industry where there's a financial benefit for them as well as a benefit for the mission? Is that possible? How would we think that through?
I think there are tremendous opportunities. I think when we go to Mars, it will be NASA run, but there are tremendous opportunities to integrate all these new commercial entities. I mean, we already are doing it. You know, of course, all the people developing the hardware are commercial. People make it sound like it's all the government's actually building all the hardware. They're not. But as you mentioned, technologies like AI or VR, these are all industries that are currently working on technologies that are interested. We just had a conference where we highlighted a lot of these technologies that will be integral when we go to Mars, not only when we're actually there for the astronauts and the scientists back on Earth, but ways to bring along the public along with us, you know, through all these new technologies, but also areas kind of like with that benefit to Earth. We were recently doing programming on, you know, in partnership with, you know, the agriculture industry. We need to learn how to grow food on Mars, utilize water. And so there are all these different areas of technology which going to be able to, areas which you wouldn't imagine right now. You don't think of traditional aerospace industries, but this really runs an enormous range of different types of industries and capabilities that will be required to go to Mars and will come back and benefit us as we learn to do better agriculture in arid locations like Mars, or extracting water, or power, you know, better power utilization. So I see this as critical, and as we move forward, we need to integrate this in the overall plan, not just internationally, but find ways to build these public-private partnerships.
And that's, you know, and I don't, in my comments, I'm saying it's different when you have private industry investing as opposed to being a contractor. I get it, they're selling their services as a contractor, they're doing it, the government's contracting it. But how do we get a company to say, we want to actually invest in the Mars mission because we'll put our own money in. We're not expecting taxpayers to contract with us. We're expecting we will invest our own money in this because we believe a successful Mars mission pays off to our investors. I don't know.
Oh, they already are. You know.
So the private business is investing now in
private is investing in a lot of different technologies, very enthusiastic. Obviously, companies, there, you know, a lot of major companies have heard of are investing their own funds, you know, to advance Mars missions. But going back to these other types of technologies I mentioned, like VR, AR, but also agricultural elements, I know of a number of companies that are actually, they're excited about it, they're investing in it, they want to take part. Yes, they're going to want a contract some point in the future. They hope to be part of it, but it's not all about money. They're excited about participating in Mars exploration and helping to create a more successful mission. So there are companies that are investing right now. Do we need more of it? Of course we do. We want to find ways to stimulate that, but it's already happening.
So if I might add to that, this is a special opportunity. There's two types of private investment that you might experience relative to space. There's companies making investments in order to position themselves to win government contracts, which means that ultimately the government is still paying for all of this. Then there are investments that companies make because there is a commercial business case that can be closed. A few moments ago, I referred to the tremendous natural resources and the potential for commercial activity in cislunar space. Because going to Mars needs to pass through, if you will, the moon in order to do research and develop the key technologies, that creates an environment that is perfect for public-private partnerships for companies that want to leverage that research to then develop natural resources from the moon, to mine ice for propellants, to tap the industrial metals that are in the near-Earth objects and invest their money because they can close a commercial business case within a relatively short horizon by teaming with NASA, furthering NASA's goal while enabling this cislunar, economically independent and self-sustaining econosphere.
Great. Thank you.
Add
Dr.
quickly
Newman.
onto that, I agree with Tory. And so I think when we look at the public-private partnerships, I had the pleasure to be in charge of when I was at NASA with 120 countries and over 1,000 of them, so that's a lot. And it just depends on, a lot of it has to be government-led, I do believe, space agency-led when we talk about Mars. That's what exploration is about. When we get closer to home, low Earth orbit, the small sat business case, they close. So we need to further that. That's where industry is going to step up and the business case really close. So closer to home and then in cislunar. It seems that those business case closest. But when we talk about Mars, have to think that, again, government leadership really moving out to say, this is what we're going to do as the U.S., and there'll be great private partners, and there is a new model under our public-private partnerships. Industry is really coming to the table, and they really are putting in a lot of their investments. So I think we have to get that model right in the public-private partnerships. But destination, how far away we go from Earth really makes a big difference in the business case.
Great, thank you.
I would even add one more thought, which is, in his opening remarks, Senator Nelson talked about needing to be careful that the endeavor of going to the moon does not distract us from our ultimate goal of going to Mars. These two things are linked. There is logistic support and activity around the research that will happen at the moon in order to go to Mars that will allow NASA the opportunity to quickly transition those activities to commercial companies for commercial uses. And that is how NASA will be able to stay focused on Mars as the ultimate goal and not get bogged down in logistics associated with being in vicinity of the moon.
Great, thank you.
Well, and let me echo something Mr. Bruno said in terms of talking about the opportunities of commercial space. One of the reasons we've seen some of the advances we've seen in recent years is because of the very beneficial collaboration we've had between the public sector and NASA and the commercial space industry. And at the end of the day, the commercial sector is going to be able to invest billions more in dollars to getting this job done. And I share your optimism about the potential, and indeed I've predicted before that I think the first trillionaire that we see will be made in space. I don't know who it will be, and I don't know what they will discover or what they will accomplish, but I think it is every bit as vast and promising a frontier as the New World was some centuries ago. One of the things that's been gratifying in this time of deep partisan division on so many issues is that space has not been one of them. That we've seen under President Obama, we've seen under President Trump, a cooperation in the Senate, in Congress, between Democrats and Republicans, committed to maintaining space exploration and America's leadership. In the past several years, we've passed bipartisan legislation authorizing NASA, commercial space launch legislation, one signed by Obama, one signed by Trump. We're in the process of taking up, and I hope passing, yet a second round of commercial space launch legislation that I just recently introduced. And the intention is to take up a longer-term NASA authorization bill. The one we passed last year was the first one in 7 years. It was an important milestone, but it was designed to ensure continuity. This next NASA authorization, the hope is that it will reach further and be bolder in aspirations. And so I guess the question that I would ask this panel is, if the objective, as all seem to agree, is getting to Mars and getting to Mars by the 2030s, are there elements that any of you think are particularly important for Congress to include in the NASA authorization legislation to facilitate that, to accelerate that, to remove barriers that may stand between us and getting to Mars?
I would say two things, and one of them you have already alluded to, sir, which is stability in the national goals and the funding associated with that, so that there are not fits and stops and starts and loss of vital workforce, as I alluded to a moment ago. The other thing that I think we need to be mindful of, I mentioned in my opening remarks, from the standpoint of the launch industry, this is a flat marketplace. If anything, expected to have a temporary dip. It's essential that we have a healthy industrial base. The thing that is unique about our system in America is that we have a partnership between government and industry. NASA and its industry partners work together. That's why we have the greatest technology in the world. It's why we can aspire to tremendous goals like putting boots on the Mars and putting a permanent presence there. The industrial base must be taken care of. And so at a time when the other commercial demands for launch, for example, are low, then we need to make sure that we have a healthy, competitive set of companies in America, and we do that by keeping those investments at home in our own industry.
One of the critical things I think is actually needed is something we've gone over in one of our previous workshops, brought aerospace professionals together, and we created kind of outlined probably about a dozen long pole technologies. These are technologies we need to start working on pretty much immediately if we have any hope of landing humans on Mars in the 2030s. These include entry, descent, and landing, as Dr. Newman mentioned, and other things like ECLIS, ascent. Some of these technologies are going to take quite a while to actually achieve, and if we can't just wait until we're at Mars and then say, oh, now we have to figure out how to land. So we have to start working on them now. We have to outline which ones, plus outline which ones have direct overlap with lunar exploration, first defining what lunar exploration means in the context of what we're going to do, but then figure out which ones have direct overlap, so we can actually start working on those specifically. Another thing I think which was already actually mentioned in the 2017 authorization, better integration with the mission directorates and the partners to make sure they can move ahead efficiently. So like human exploration and science and technology can all work in tandem, towards that one goal. So there are probably dozens of other things I can mention, but I'll leave it right there. Thank you.
Yes, constancy of purpose. We like to call that. Advanced propulsion, smart habitats, incorporating all of that autonomy that is, we're on the edge of right now. Entry, descent, and landing. Bioregenerative life support systems hasn't been mentioned. Suits, in situ resource utilization. That's what we do when we get to other planets. That's what explorers always do. We live off the land, so we have to figure that out. We have to make the habitats out of our basalts. When it comes to humans, radiation is the number one. We need to work on that more. But the human factors, the mental well-being of folks far, far away, we can't trivialize that. Really need to take care of the safety and wellness of our astronauts. Musculoskeletal, we're getting a handle on that. And this, I just back my final comment, is this integration, that just doesn't, that's really functional. That's really the functional organization that's hard, because we can't have the stovepipe, so we really need science, technology, human exploration, one pot of money. So that's why I call the Mars Program Office. That would be the true integration. I think we could get there.
If I could add one more thought to one of the things that Dava brought up. I hear a lot of debate and assertions in this question that, well, this is a great human endeavor and there's going to be risks, and so we're just, we're going to tolerate people being lost. And it is true that there are inherent risks in going to space. Space is a physics-defying act, and it is not possible to make it risk-free. That's a fact. However, there is no reason that we need to take unnecessary risks with human life. Our astronauts are sons and daughters, mothers and fathers, husbands and wives, and it is not acceptable that we take risks with their lives and well-being that we can avoid and apply our ingenuity and our industrial and technological might in order to mitigate?
Well, I will go back and just reiterate that the one most important thing is constancy of purpose. We have to have a vision that lasts more than one administration. We have to have a budget line that will support those goals and objectives that we are striving to reach. And to me, I think that will help us solve a lot of the problems.
Well, thank you very much. Let me thank each of the witnesses. I would note on constancy of purpose that has been one area where we have seen wide agreement in Congress and in the Senate. And indeed, we began the NASA authorization endeavor in the previous administration and continued it through to this administration precisely to avoid the sort of cancellations we've seen in the past, whether with Constellation or otherwise, and the billions of wasted dollars and frustrated man-hours that were lost. And so let me thank each of the witnesses. This has been, I think, a very productive and informative hearing. Thank you for your lifelong commitment. This is a labor of love. Nobody is confused that you are doing this for anything other than passion. We will keep this hearing record open for 2 weeks. There may be senators who submit follow-up questions, and the witnesses are asked if there are follow-up questions to promptly respond to those. And with that, this hearing is adjourned.